Okay, now that we've been working with our radicals and we're getting used to how they look, our next section, 8.5, is products with radicals. So anytime you have a multiplication problem, we're going to see how to use the radicals in it. We definitely want to rewrite or simplify these expressions, and again, continue to apply our properties of radicals and nth roots to these different problems. So let's start with, we want to simplify. And if we simplify, you're saying, well, wait, we have the rule that you could either multiply them and simplify separately, or, as I said, multiply them out. Now, if you first look at it, what's that one number that multiplies by itself to give me a 4? Oh, sorry, I should say multiplies by itself 3 times. And there is not a whole number, so that's not looking good. And if we do the same thing with the 16, what multiplies by itself 3 times to give me 16? Well, okay, nothing for 3 times, but 4 times. So in this scenario, it is best, because you can't break them down, is to go ahead and multiply the two. Because we have like radicals, we can do that. We have both cube roots, so you're going to say I'm going to end up with a cube root, and now all you have to do is multiply the two numbers underneath. 4 times 16 is 64. Now you have a bigger number, maybe more possibilities, but here we go. What is that one number that multiplies by itself 3 times to give me 64? And your answer should be the whole number 4. So in this case, it was definitely better to combine the two like radicals by multiplying what was underneath, making it a bigger number. That bigger number then could be broken down. That's not always the case, but it is something to check. Now, the next one says write as a single radical. So you have no choice but to go ahead and multiply it. And again, because they are like radicals, you can multiply. And the rule goes as follows. Numbers times numbers, like variables times like variables. So we know we're going to get a 7th root. So squeeze in that little 7th sign, or make it a little wider at the beginning. And here we go. 2 times 7 is 14. Normal multiplication. T to the 4th times t to the 2nd is t to the like bases, add the exponents, t to the 6th. So now you want to look at it and say, well, what can I break down? Ask yourself, I think it's pretty obvious that t to the 6th is too small to come out of the radical, but what about the 14? So you start multiplying. 2 times 2 is 4, times 2 is 8, times 2 is 16, and we only multiplied 4 things. So I don't think that 14 is going to be a perfect combination. I am now a single radical, and that combination would be our answer. 7th root of 14t to the 6th, because nothing can come out of it. Nothing can be simplified. Next, we want to rewrite the expressions and simplify them if possible. And again, assume all our variables are non-negative. So yes, I could take out a negative or take out a variable, and it's going to come out as a positive number. So we're doing square roots on the left and 4th roots on the right. Let's start with the square roots as sort of our warm-up. Perfect combinations of 2. So first, what's the square root of 4? I'm hearing most of you say 2. And what is the square root of y to the 6th? Remember, how many groups of 2 can I take out of y to the 6th? And y to the 3rd is the correct answer. So 2y to the 3rd is the final answer on that one. We have nothing left under the radical. Next one. If I'm doing the 81, I'm going to look at the 81, then I'm going to look at the x, and then I'm going to look at the y. And you have to look at them as 3 different things, because they truly are 3 different pieces to what's underneath the radical. 81 is a little bigger number, but let's try it. What multiplies by itself 4 times to give me 81? Well, we know 3 times 3 is 9. Well, there'd be another 3 times 3, and 9 times 9 is 81. I think we found our number. So I got a 3 coming out. Then it's a 4th root, which means groups of 4. X to the 8th in groups of 4 is x to the 2nd. Good job. Y to the 3rd taken in groups of 4. Oh, there's a problem. We cannot take a group of 4 out of that one. And we'll end up keeping that y to the 3rd underneath, 3x to the 2nd, times the 4th root of y to the 3rd. That's as simple as you can get. Sometimes you have perfect combinations. Sometimes you have a mixture. All right. Now, if you remember, You have talked about an arithmetic mean before. So if I said out of either of these two words, this top one is the review combination. So an arithmetic mean. It's a fancy name for nothing more than, I'm hearing average. So average, arithmetic mean. So if I said, definition of an arithmetic mean is add up all the scores and divide by the number of scores you have, that's the same as doing an average of your data. We're used to that. That's arithmetic. Now today, in this new section, our discussion is, what about geometric? So geometric, there's a little different definition. Check and see if you have it in your notes after reading. And if not, then you need to copy the following. It's your process you will use. Multiply the numbers, then you will take the nth root. Now, nth means basically how many numbers you have. So take the nth root of the expression, representing how many numbers you actually have in the expression. So I have one here you can try, and it says, find the geometric mean of the integers 1 to 10 to the nearest hundredth. All right, so you're either going to multiply them in your head or with your calculator, and get going. And you should get a number, and that number then you need to take the, in this case, 10th root, because we had 10 numbers we were multiplying. And you can take the 10th root either with the root key or with your fraction. Look. And again, read directions carefully because they ask for a answer rounded to the nearest hundredth. So looking at what you got, I know what I got on my calculator. So let's see if we're all correct. Reveal says, final answer, 4.53-ish. On my calculator, I had a 4.5287-ish. So by rounding up to the nearest hundredth, that digit of 8 would turn the 2 to a 3. So please add that to your list of definitions. It's a whole new process, actually. And an arithmetic mean is nothing more than an average. That's another thing you will probably want to add to your notes. So let's put that up here. In doing an average, you are really doing an arithmetic mean. So a geometric mean is a little different. It's the multiplication process and taking the nth root. So a little more practice in our radicals, simplifying, but I don't think anything drastically new overall. So get a little more practice and bring any questions you have to class.